Kind of try to get them both done. So, this is going to be kind of a random lesson. We will do this lesson, we'll practice it, we'll take a proficiency quiz. This one won't be on the test though, because we are finishing off the last lesson from last chapter that we didn't have enough time before the quarter ended. So it's kind of a random one, kind of like the first one we did the last quarter, but this one will be a little easier, I think. Alright, so what we're going to look at today are domain and range. So we're going to identify the domain and the range, and then we're going to actually skip this part, this next part. I forgot to delete it. We're going to represent the relationship with the mapping diagram. We're not doing that part because they're kind of annoying to make and they're not as helpful as like. So we're going to skip that part, but then we're going to say, is the relation a function? So we're going to start off by identifying the domain and range, and we're going to kind of bounce back and forth between a couple of slides. So, domain. We're going to look at part A here, which is these lists of XY coordinates. A domain is all the X values from smallest to largest. And I forgot to put this in. Oh no, I did put it in. That's right. When we look at domain and range, we never repeat numbers. So if I'm going to list my domain, I'm going to take all my X values, and remember X are these numbers in front right here. X, 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 X. We're going to go from smallest to biggest, and we're just going to list them. So my smallest is -2, and then 0, and then 4, and then 5. Sometimes they're nice like this, sometimes they're not. So this one's nice and easy to list my domain. So I'm going to go -2, 0, 4, 5. And when we talk about domain, we put it in these little bracket thingies. These little bracket things right here, which look kind of like this if you can't see them. Like this. I don't know. I'm not very good at making them. They're supposed to be like a little bump in the middle of it. I'm not very good, and this is good enough. So when we talk about domain and range, put them in brackets. It's how you show that it's the domain or it's the range. Kind of like, this is an XY coordinate up here, right? We put them in parentheses. For domain and range, you put them in brackets. So I've got my domain for part A here. My X values from smallest to largest. And we're going to list our range, which is our Y values from smallest to largest. And when I do these, like I said before, you never repeat numbers. So if I'm going to go through and look at my smallest Y, over here, I've got Y, 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 and Y. My smallest Y is 0.5, right? And then I have 2.5, but 2.5 shows up twice. When I list my range, I'm only going to write it down once. I don't need to repeat it. So I'm going to go 0.5, 2.5, skip the second one, and go 6.5. So my range is 0.5, 2.5, 6.5. I'm not going to repeat it. So never repeat numbers in your domain and range. Gotta be careful and make sure sometimes it might look like they repeat, but one of them is just a negative. They're kind of sneaky sometimes. I like to be sneaky like that, it's fun. But don't repeat them if they're exactly the same. So we're going to look at part B here, and we're just going to list the domain and the range real quick. So my domain is all my X values. So I have an X. The first one is always X in these XY coordinates. X, and then let's have you guys help me out. I think we're at trading. What's my first domain going to be? My first number. Six. What's the smallest? Number smallest to biggest? Oh. 4. So I'm going to draw my little bracket thingy. Looks terrible. That's okay. 4 is my smallest. And you know what? Just to help myself out, I'm going to cross it out so I know I already used it. Actually, no, I'm not going to cross it out because we're going to need to look at it again. And some of you guys might be doing some pins. Let's not actually cross them out. I'm just put a little dot over it to show I used it. So, my first domain is 4. Richie, what's my next domain? 6. Yeah. Oh, 5. 5 is smaller. So I'm going to go 4, 5. Allison, what's my next one?
6.
I'm going to go 6 for my next one. And then, Zoe. There's still one more domain. What's that last number that we haven't written down yet? Or that we haven't done anything with yet?
Oh, there's another 6.
There's another 6, right? But are we going to write it down?
No.
No. I already have 6. I don't need to write down the second 6. That's good enough. So I'm just going to leave it like that. It looks a little bit better. Bracket. Not great, but a little bit.
It's a 3.
No, but I agree. I think I made a really bad 3. Yeah. Alright, so we just listed our domain, not too tough so far. We're going to list our range next. So I got my y's, 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 y's. Jared, what's my first range going to be?
3.
Let's see, looks like my first one is 3. Okay. Willem, what's my next one going to be?
Oh, what?
What's my next range going to be?
Range?
Yep. So range is our y's. So if I did 3, we're going from smallest to biggest. What am I going to have after 3?
4.
4 is right there. Little dot, so I know I used it. Alright, we'll keep going. Dylan, what's my next one?
5.
And then what's my last one, Juice?
8.
Last one was 8. Alright, so 3, 4, 5, 8 is my range. Not too bad so far. Okay, we're also going to say, is the relation a function? So we kind of have to jump back and forth a little bit on some of these slides because I couldn't fit it all in one. So, a function is a special kind of equation. And when we look at functions, well, I'll talk about it more later, I guess. But for a function, every x must match up with exactly one y value. So to determine if you have a function, check your domain. If your numbers never repeat, then it's a function. So for every x, I have to have exactly one y. And basically what this means is I need to make sure my domain, the numbers in my domain, never repeat. So I'm going to look at part A right here. In part A, does the x value ever repeat? Do I ever have exactly the same x value twice? No. I have -2, 0, 4, 5. They don't repeat. So because this doesn't repeat, every x matches up with exactly one y. When you say, is it a function, don't look at the range, look at the domain, look at your x values. Because they never repeat, I'm going to say, yes, it's a function. Because every x matches up to one y. I'm going to go, yes, function. For part A. And we're going to look at part B next. I want to know, is this a function, yes or no? Does my x's, my numbers in my domain, do those ever repeat?
Yes.
Yes. We have a 6 here and a 6 here. It repeats. That means this is not a function. It's not a function because x matches up to 5. When x is 6, it matches up to 5, and it matches up to 4. We can't have x's match up. And we're not really going to get into this right now, but what this means, basically, to be a function, when you graph something, you can't have something above another thing. You can't have a dot above another dot. So you can't have like dots piggyback on each other. So if I was going to graph this real quick, if I was going like 1, 2, 3, 4, 5, 6, and then if I was going 1, 2, 3, 4, 5, when x is 6, y is 5, right? Go over here to 6 and up to 5 and put a dot. When x is, and then also when x is 6, y is 4. Here, put 4. You see how these dots are like piggybacking but directly above each other? We don't want that for a function. We don't want them to be right on top of each other. No piggybacking for functions. So we're not really going to do this right now. I just kind of want you to know why it's special. So functions need to be nice and smooth and no piggybacking. So for example, if you were to have dots just kind of like this, kind of separated, that would be a function because they're not on top of each other. There's no piggybacking functions. Alright, for your first in-class problem, I want you to, in the box here, I want you to label the domain and the range, and then determine, is it a function, yes or no? So find your domain, find your range, and then say, is it a function, yes or no? You got a pencil one?
I think so.
Yeah. Gotta take some notes. These notes are worth points, plus I'll let you use them on tests. Or at least some of them on tests. So go through, just or write down, I almost said type in, write down whatever I write down. These ones in the boxes, I call them in-class problems, and for you to practice on your own, then we're going to talk about it and see if you get it right. So do it on your own, and then your partner's not here right now, but if he was, check, see if you get the same answer. If not, talk about it, and then we'll do it on the board. What's called in this class? That's what happened.
Hey, go
Switch that around.
Googie.
Yeah.
If you're in this class again, does that mean you're not getting classes the first time? Or you just
What do you mean? Like this quarter?
yeah.
No. It just means Quana had some weird schedule thing. So he must have needed a semester of this class, and he's still going to be in geometry.
Oh, okay. I want to be in geometry. Am I going to be in it?
Next year. Next year you'll be in geometry. Where are you, Richie?
I want to be in geometry.
So I'll give you another minute. Work on this problem, label the domain and the range, and then tell me, is it a function, yes or no? And we'll have somebody do it on the board. What?
I don't even know
What we just talked about.
Goal key.
What's it say up here?
I don't know, I got distracted.
You always must have one of each, and you have to have them at the smallest margin.
They would match
Oh, yeah.
exactly. One wide back, one.
Mhm.
I think I'm ready.
So look at your domain. If in your domain, your x they never repeat,
Nope.
then it's a function. So look at your x's in your list.
They repeat.
That's not a function. Because which number is it?
Smaller than these.
Two. So it's not a function.
So if they never repeat, it is a function. If they do repeat, it's not a function. It's kind of like a flip-flop type of thing. If your x's don't repeat, then it's a function. If they do repeat, it is not a function.
Wait, I have a question.
Yeah.
So do we say, if we have a yes or no, is it that, just say yes function?
Yeah, you can just say.
Overall, just not a function? Or just
pork ribs? Yeah.
Man, this makes way more sense now.
Alright, we can pick somebody random, do this on the board.
Me.
Can I be the random person?
Me.
Calculator chooses you. And it is lucky number. Oh, guess who it is, Juice?
I want to be.
Alright, Jocelyn.
Just because
Just write the domain. Just do the domain once. Yep.
I like those.
Lost
No,
After
you
lesson?
want to sit by yourself, so you're over there. So.
No.
Alright.
Never get picked once I sat in that seat.
So Jocelyn's gonna do the domain for us. Yep, right there.
Isn't the domain the smallest?
The x's from smallest to biggest. Yep. So what's your smallest x?
Um,
What?
Oh, be careful. Isn't negative 2 smaller? Yeah, it's kind of sneaky. Remember, negative, actually, even smaller is negative 7.
I have man arms.
Did we ask?
Oh, talking
Alright, so our smallest domain is negative 7. Alright, so we did negative 7. What's a little bit bigger after that?
-2.
So keep going. So negative 2. Negative, there you go. Negative 2. Alright, keep going. What's going to come after that?
4.
And now, oh,
But
not 4. Sorry, I thought you said
1.
1.
Oh.
Just cross it out, yeah. Save some time. Good enough. That's a 1. Alright, and then what's after 1? What's our next biggest?
2. -4.
Yep. 2.
Oh my god.
Nice save.
I'm pretty tired.
Alright, and then
4.
what's our next biggest after 2? There you go. And then our last one? 7. And normally when you write these, put them in little brackets, but I won't make you draw them. Alright, for our next one, Kyle, give me the range.
Might.
I can't believe you've done this.
I thought you can pick me, man.
You were so
I
close.
can't believe you've done this. I really can't.
We're one desk away. Kyle's on his brackets, making me look bad. Alright, what's our range, Kyle? Okay, -8. Smallest to biggest for our y's.
That's there's a 1.
So we got -8.
That's some pretty nice
One.
writing you got there.
2. Yep, that's it.
Honestly,
Sign that. It's not that good. You can go on artwork later. Alright, and then our last one, Dylan. Tell me, is it a function, yes or no?
oh my.
Is it a function, yes or no? What you got? I don't know. Oh. Why isn't it a function? Why not?
That's abuse to the cat.
No, it's not.
It is.
I
Don't-
watch your pets repeat.
Which one repeats?
All over herself too.
That's why you let them lick themselves. That's what they get themselves.
Hey, hush, we're going over this. Why isn't this a function, Dylan? When we look at functions, though, what do we look at, the domain or the range? Domain. Does the domain repeat at all? No. So this is a function. So be careful. This is a function. It is, because your domain doesn't repeat. Your range repeats, but the range doesn't matter. All we care about when is it a function, yes or no, is your domain. So this is a function. So it's not just no repeats, it's no repeats in the domain. There we go.
Not a function.
Can she change?
Oh my god. It's not good
Oh,
that.
9.
You could have got it right the first time.
We do our warm up now.
Alright, so we're going to have one more piece. So, not only are we going to list domain and range from lists, we are also going to calculate some domains, or excuse me, calculate some range when we're given some domain. So, we're going to look at f of x equals x plus 3. And this is a function. This is how we say function. So, you know how last time we've always done like y equals x plus 3? That f of x right here and y, they work exactly the same way, except when you see f of x, that lets you know, oh, this is a function, it's kind of special. For every x, there's exactly one y. There's no piggybacking when you graph it. There's no dots above dots. So even though it's f of x, it's going to work exactly like y. And what we want to do is we're going to say, what is the range if the domain is 1, 2, 3, and 4? And what this means is we are going to plug these in for our x's. So domain is x's, right? We're going to actually do a problem 4 times. And each time, we're going to plug in a different x. So I'm going to start out when the domain is 1, what's our range? I'm going to take this number 1, and I'm going to plug it in for my x's over here. So I'm going to go f, and instead of x, I'm replacing every x with the number 1. I'm going to go f of 1, like this. When you talk about functions, you read it as f of, and then whatever's on the inside. So we read this as f of x equals x plus 3. We would read this as f of 1 equals. And that's how you say it. And I'm going to plug in 1 for my x, and then we're going to calculate it. I'm going to go 1 plus 3. I put in my 1 for this x right there. And then I plug in 1 for my x. And when I look at functions, I don't need to solve anything on this f part. It is just to show me what I plugged in. I plugged in 1, and I'm going to get 1 plus 3 out of it. What's 1 plus 3?
4.
I plugged in 1, and I got a 4. I only need to solve this piece over here on the right. So it's just like a calculator problem. You just plug it into Desmos and see what you get. So I don't do anything with this except plug in the number for x. and then I solve the right side and just get rid of equals. Richie, go away. Else. So I plugged in 1 for my first thing. We're going to do basically the same thing, except this next time, I already plugged in 1, now I'm going to plug in 2. I'm going to plug in 2 for my x. Now I'm going to find out what does f of 2 equal. So I'm plugging in 2 for my x, so I'm going to go 2 plus 3, which 2 plus 3 is 5. So f of 2 equals 5. Okay, we're going to keep going. I plugged in 2, I'm going to plug in 3 now. I'm going to go f of 3. And find out what does f of 3 equal. So I plug in 3 for my x, I'm going to get 3 plus 3, which is 6. And then the last one, I'm going to plug in 4 in for my x, find out what f of 4 equals. It's going to be 4 plus 3, which equals 7. Okay. Have we written a range yet? No. Remember, range has those brackets. We haven't written anything with brackets yet. So we've actually done all the work, but we have to actually write it as a range. So for my final answer, I'm going to take all the numbers I got, 4, 5, 6, 7, I'm going to write them like my range. Smallest to biggest, no repeats. So 4, 5, 6, 7. This one's kind of nice because they're nice and in order already. So this is my final answer. I plugged in my x's. I plugged in numbers for my x's, for my domain. And out of that, I got my range. Which are these. This is my final answer right here. Final answer. And this is it, all we're working on, so we're going to practice it a little bit more, and then you guys can do one, and that'll be it. Everybody got this down? So we're going on. You got it, Trey? Yeah. If I go too fast, just let me know and I'll slow down. Alright, let's shorten this up a little bit. Let's actually only plug in 2 different things on this one, just so we have a little more time. So, the domain of f of x equals negative 1.5x plus 4 is 1 and 2. What is the range? So, same thing like before, I'm just cutting down numbers to save time. So, I'm going to have to plug in different numbers in for x. I'm going to start with 1, and then I'm going to plug in 2. So I'm going to start with f of 1. I'm going to plug in 1. F of 1 is going to equal negative 1.5, and then, where am I? Alex, what's in between this negative 1.5 and the x right here? Even though we're not writing it down.
Is it minus or no times?
There's a times right in between there. So when I write this out, I'm going to go negative 1.5, and then I'm going to go times 1, like that. So I know that there's a times in there. And then at the very end, I got this plus 4. Like that. Now that I got it written down, what we're going to do is we're just going to plug this whole thing into Desmos. Unless you can do negative 1.5 times 1 plus 4 in your head, which is possible, but probably not, just because it's got that stupid decimal in there. They're annoying. So let me grab Desmos real quick so I can plug it in. So negative 1.5 times 1 plus 4. Negative 1.5 times 1 plus 4. I plug it in Desmos and I get 2.5. So, I'm going to go back to my notes here, maybe. There we go. And I got 2.5 out of it. So I plugged in 1 for my x, for my domain, and I got 2.5. Do the same thing, but this time we're going to plug in 2. I'm going to find out what does f of 2 equal. And it's negative, just like last time, negative 1.5. There's a times in between there. And I'm plugging in the number 2. And I got a plus 4. And I'm just gonna plug this into Desmos. Just because I don't like doing that in my head. Nope, I missed it. There we go. With that, type in the number 2, and I get 1. When I plug in 2, I get f of 2 equals 1. Alright. We're not going to do those last 2 numbers to save a little bit of time.
So just exit ticket.
No, I'm saying we're not going to plug anything else in. You guys will still have one. Maybe you're going to take it. Let's see. Alright, and then I'm going to list my range because I haven't actually listed it yet. So I got my bracket, and then what number is going to come first?
2.2, 2.5.
What do we do when we list domain and range?
Oh, it's so.
Smallest to biggest. So this one is actually backwards. My smallest number is 1, and then 2.5. So this one is backwards. So you got to be careful because your range, smallest to biggest, no repeats. So as you do this, you might not write down every number because it repeats. Alright, we've got about 10 minutes left, so what I want to do, I know we haven't done an in-class problem on this, but I want you to have some time to at least, I want you to answer your exit ticket problem. So we're going to skip that in-class problem, and then on your exit ticket, we're just going to do the exit ticket. So, for the first part, you're going to list the domain and then list the range. For the second part, it's just like what we did, but you're only plugging in one thing. You're plugging in the number 2 in for x. So when it says what is f of 2 for the function, that means plug in 2 for your x and then calculate it. So, on this last slide, we plugged in 2 things. On this slide, we're just plugging in 1 on your exit ticket. So, on your paper, start answering these. I'll turn on Socrative, so you can do your exit ticket on Socrative. And then I'll put your homework on Google Classroom, and you guys will have about 10 minutes to get started on it. And then tomorrow, we will practice this some more.